In 2013, globally, as a society, we spent approximately $70 billion in security technology. $70 billion. In 2014, that number grew to $78 billion. In 2015, it's going to break that record again. We keep throwing more and more money at the problem. And the reason we do that is because, well, we can justify it. Malware is getting more sophisticated, hackers are becoming smarter, more attackers are getting online, the Internet of Things is causing more of our lives to be interconnected on the Internet. Everything from our thermostats, our refrigerators, our microwave ovens, now our cars are hackable, airplanes are connected via IP, so we have to throw more money to the best technology to solve these problems. But what's happening, though, is the problem is getting worse. The more complex, the more money we spend on security technology, the more security professionals we have to hire, the more we have to train them. And the more money we spend, there's less of a budget left over to put toward our actual business. So we're spending more time and resources protecting data as opposed to using the data to run our best practices by companies that I've seen. And a lot of this is, a lot of it's common sense, and some of it may not be. Data classifications is very key. We have all kinds of data, and when you think about it, that's what attackers, cyber criminals are really, they're after our data. They're not trying to steal infrastructure, they're not trying to break into a building necessarily, they're after data. Data is becoming more and more of an asset on our balance sheets. Even though it's intangible, it's classified still as an intangible asset, but it's becoming the most valuable item that we have in our organizations, in our lives. That's what hackers are after. But it's amazing to me how many chief security officers I talk to that have no idea what the value of the data is worth. And I think that might be an accounting problem. We need to change our accounting rules so it's easier to put a value on data. Because once you put a value on data and consider it to be an asset, then you can justify spending money on the most valuable data and spending less money to secure less important data. Too many times I've seen, not only do CISOs and chief information officers not know the value of the data, they don't know where the data is located, and they don't know how the data moves in the organization. They're very good at tracking cash flow, but they're really bad in general at tracking information flow. We can't solve the problem until we know where our data is and how much what its value is. And a lot of this, one Fortune 50 company chief security officer confessed to me that they are acquiring companies so rapidly that it's impossible to keep track of where the data is. New forms of data are coming in with every acquisition. These acquisitions bring new security policies, new security infrastructure, and it's a nightmare to manage. And he is absolutely convinced, and I can't name the company, of course, but he's convinced that he's already been breached. That's just a fact of life. He has to accept it. So understanding where your data is located so you can understand how much to spend to protect it is absolutely critical. And this is a fundamental part of having a risk management program. The second item is understanding your applications. Applications continue to be the most vulnerable entry point, the most vulnerable attack surface for hackers. And the reason for that is most applications are not written for security. They're not written with security in mind. They are written to enable business to move more quickly. And so many applications that we have out there today are written by custom programmers. They're not off the shelf. They haven't gone through a lot of testing. There's a lot of pressure on developers. I'm sure that you folks have many, many developers on your teams, and you're pushing them to get applications done faster. There's a whole security-driven application development lifecycle practice that we should all adhere to when writing software because these vulnerabilities come up all the time. If you ever log into US CERT or subscribe to US CERT, that's the US Computer Emergency Response Team website, and just have them send you news feeds. They'll send you a daily list of the vulnerabilities that they have discovered in software. And it's alarming to see how many vulnerabilities exist and are uncovered in critical infrastructure software, the software that runs our power plants, our nuclear stations, our transportation systems. They're uncovering vulnerabilities in the software all the time. And what's really alarming is that we're only catching a small percentage of the vulnerabilities that exist. I talked about cybercrime as a business. One of the biggest and fastest growing areas of cybercrime is discovering zero-day vulnerabilities in critical infrastructure software and business software, and then selling that vulnerability not to the developer who wrote the software. That would be too good. There's no money in that. Selling it to cyber criminals or rogue nations, especially rogue nations, so that they can sit on that vulnerability and begin exploiting these vulnerabilities. I mean, strange things happen out there. We see power plants getting shut down. We see water pumping stations ramp up, and it's like a lot. I stay up at night worrying about all these little variants of Stuxnet that are all over the place. How many of you have heard of Stuxnet? Stuxnet is a piece of malware code that was jointly developed between the U.S. government, allegedly developed between the U.S. government and the Israeli government, and it infiltrated the centrifuges in Iran and basically caused those centrifuges to spin at such a high rate that they destroyed themselves, while the monitoring system of those centrifuges reported back that everything was absolutely fine. Very sophisticated piece of malware, and it was allegedly distributed or implanted in Iran's nuclear research facilities on pen drives that were dropped off in the parking lot. That's another thing. Don't pick up a pen drive and plug it into your laptop. I talked to some people a little bit earlier today, but I consider a pen drive to be somebody else's toothbrush. I would never use it. You'll never forget that. It's kind of gross. So understand the applications. Also understand your IT infrastructure. Simplicity is key. Complexity introduces more risks. I can't tell you how many data centers I've walked into from client companies to see such a mess. Now this is, the folks from VMware are going to love this. I honestly believe that cloud computing is a safer, cloud computing providers provide a much safer environment than most of the IT data centers that companies run on their own, because it has to be very efficient in order for them to make money. They do this as a business. We wouldn't run our own power plants as manufacturing companies did 100, 150 years ago. Why would we try to build our own data center infrastructure and run it ourselves? It's not core to what we do. Those kinds of things should be outsourced. But the key here, I have seen organizations grow so rapidly that they'll put, one company in particular, put a database server, application server, and web server all on the same VLAN, and thought, well, I've got a firewall in between the internet and my web server, so I should be safe, right? Well, no, they were breached, and we got in, and the only reason we discovered that vulnerability is because they were in the process of migrating to a cloud computing environment, so they needed to redo their architecture. And in the process of us doing that migration assessment, we discovered databases on their own servers that were created by hackers. They were getting ready to exfiltrate tens of thousands of credit card records. But luckily, they caught it in time. There was nothing in the log files that indicated that the data had been exfiltrated. But really understand your infrastructure and look at it for security as well. Number 4 is understanding and accepting the new normal. Understand what makes you a target. Understand that you are a target. Are you receiving threats from internal or external? These are all indications. Physical breaches are also something that need to be taken into consideration. Is your business or your organization doing something that might attract the attention of a hacker or an attacker? Are you provoking someone? I worked a few years ago with a television network that was about to release a documentary that was highly controversial. And they came to us and said, we haven't released this yet, nobody knows about it, but once the show comes out, I think we're going to get attacked. And sure enough, they were. So preparation and understanding, having that self-awareness of where you are in the world and what could provoke an attack is absolutely essential. Understand the nature of your business. And just also understand that no matter what you do, you're going to be attacked. If you have data and it's accessible over the internet, somebody's going to try to get to that data. Don't make the assumption that your data is not interesting enough to a hacker. Breaches can happen, reported breaches happen with databases that just have a few hundred records in them. Attackers are after everything they can get their hands on. And again, compliance does not make you safe. Just because you're PCI compliant doesn't mean that your credit card data is guaranteed to be safe. The credit card industry came up with the payment card industry security standard as part of a balance. They didn't want to make the security controls so stringent and so onerous that it would drive businesses away from accepting credit cards. They made it too tough. We would resort to bank cards and checks and cash and Bitcoin and other forms of payment. But it's still a very good standard. But that standard had to achieve a balance between what will keep credit cards in use and what's difficult to implement and cost-wise from a security perspective. So you got to look beyond the regulations and standards, and you must develop a risk-based approach to managing vulnerabilities. Again, technology is not the answer. It's more about process than it is technology. And that process is a risk-based program. And what these companies do that are safest and do the most to protect their own data is establish a GRC program, governance, risk, and compliance. It's basically a process, and there's a lot of tools out there, ITIL, COBIT, ISO 27001, and yes, the PCI Data Security Standard. These are all excellent standards to follow that not only tell you how to evaluate your data, where it's located, track its movement, but also how much to spend on the technology and what to outsource to managed security providers, and how to do training, how to do background checks on contractors, and how to remind and teach employees not to pick up pen drives in the parking lot and randomly plug them in to their laptops. It's common sense practices. And these frameworks, which are absolutely essential, need the backing of senior management and boards of directors. The board has to be involved in these security standards and adoption of governance. And finally, number 6, it is absolutely essential to collaborate with service providers and peer organizations. I would not recommend anybody, any organization, trying to implement security controls all by themselves. We are way past that. We are way past the do-it-yourself phase. Security as a service can be delivered from the cloud, managed hosting providers, managed security providers. It's too hard to maintain the talent, and companies do this all on their own. Now, some of it has to be done. Governance must be done. It's the responsibility of the organization. But things that are more difficult and cutting edge, and maybe as a cost savings measure, have to be outsourced to security providers, security services providers, because that's what they do. That's their core area of expertise. Collaboration with other organizations in your same lines of business. You cannot be siloed and keep that information to yourself. In the banking industry, it has proved invaluable to share information about hacks. It's actually gone a long way to protect organizations.